Okay, I'm going to work through a solution for problem 60. In this case, it's a stoichiometry type calculation, but it makes use of the unit of molarity because we have a solution of hydrochloric acid. So many times we'll start looking at compounds, and rather than knowing their mass, we'll instead know if they're solutions. We'll know how much of the solution we have and its concentration. So what we have in this case is some hydrochloric acid. This is what we know about it. And what we're going to do is drop in a little bit of magnesium. So just a little piece of magnesium can be dropped into this solution. It will convert some of the hydrochloric acid to a magnesium chloride solution, and then we would actually see some hydrogen gas bubbles. So we're not going to react all the hydrochloric acid, just some of it. And what we'd like to do is reduce the concentration from 1.023 molar down to 1 molar. So before we jump into this, let me just remind you that what's new in this problem is that we're going to have to use the definition of molarity. So if you know the molarity of the solution and you multiply its volume in liters, what you actually find are moles of the compound. And so in this case, we're going to find moles of HCl by doing just that calculation. And again, why do we want to know moles? We want to know moles of HCl because in a stoichiometry type calculation, that's the most convenient unit to use, because up here we know that for every 1 mole of magnesium, it will react with 2 moles of HCl. So what we need to do first is see how much hydrochloric acid is in the solution. So I'm going to convert the 250 milliliters to liters and multiply by the concentration. This will tell me how many moles of HCl are present initially. Alright, so we multiply that and we get 0.2558. Let me just double check that. I haven't worked through this one yet. Okay, so 25575. Okay, so I've rounded that to an 8. Now, what we would like after the reaction, we would like 250 milliliters of a 1 molar solution. This is what we're after. And that means we want a solution that only contains 0.250 moles of HCl. So after this reaction, after we add a little bit of the magnesium, we'd like there to be just this much, 0.25 moles of HCl. So what this means is that when I react the magnesium, I need to use up or react, and so I'm going to find the difference here, and I'm actually going to use the original value, 25575. There's really no reason to round here until we get finished. So what I would like to do is react this much HCl. So that's really the starting point for my stoichiometry calculation. If I react this much HCl with magnesium, how many milligrams of magnesium are required? So I'll start with that as if it were maybe the given information for a straight stoichiometry problem. Moles of HCl can always be converted to moles of something else. The balanced equation tells us that 1 mole of magnesium reacts with 2 moles of HCl. And then we continue on now to find what we really want to know. And a mole of magnesium has a mass of 24 grams. But we're only going to be adding a tiny bit of magnesium, so let's go ahead and convert that to milligrams. Okay, so then you put this in your calculator, the difference here, how much we wanted to react of the HCl, the mole ratio from the balanced equation, and then the molar mass of magnesium converted to milligrams, and we'll get about 70 milligrams of magnesium needs to be dropped into the solution.